Okay, this video is going to be on similar triangles. We're going to find the missing side or missing piece of a side of a triangle in an overlapping triangle. As you can see, we have some overlapping triangles on the page, so we're going to go ahead and find the missing piece. I suggest that you follow along with what I do. Don't try to do a shortcut once you see me do it. It's very helpful to use the method that I used. So very first thing we want to do, well, let's figure out what the problem is. We have number one, triangle DBE. So I'm going to go ahead and start color coding things. We have triangle DBE. That's this triangle right here. Is dilated by a scale factor K. So remember, dilation means that it's going to stay the same shape, but it's going to get bigger or smaller. And we're going to move away or closer to B. That's the center of dilation. So as you can see, since this other triangle is larger, it is getting bigger. Therefore, the scale factor would be larger than 1. So what we have is triangle DBE is dilated, and we end up with triangle ABC. That's this larger one out here. So I'm going to redraw them. As you can see kind of below, it says redraw the two triangles, but for right now I want you to see the two triangles as they overlap, and then we're going to label the missing sides, or not the missing sides, we're going to label what we know. So it says that AB is equal to 12, so that's this side right here, so that's this whole side. AB is equal to 12. DB is equal to 6, and that's this side here. Okay. And DE is equal to 4, and that's right in here. That's this piece, this segment in the middle. What is the length of AC? So we're looking for, we're looking for AC, and that's going to be this side here. So you can see it looks a little confusing. There's a lot going on there. So we're going to redraw the two triangles, and we're going to label the given parts again. So we have triangle DBE, that was the original one, so that's the smaller one. We try to draw it in the same shape so we don't get confused when we look back to our original diagram. So we have triangle DBE. We know that DE is 4 and DB is 6. Then we have triangle ABC, that's a little bit bigger. So again, it doesn't have to be perfect, but along the lines of what we're seeing in the overlapping triangle diagram. And we know that AB is equal to 12 and AC is equal to X, because that's what we don't know. Okay. So the next thing that we're going to do is we're going to set up a proportion and solve. So when we set up proportions, we want to make sure that our corresponding sides are set up together the same with our triangles. We don't want to start jumping around from side to side, making no sense. So if we look at this side, DE is 4. Okay, so let's start with 4. Its corresponding side in the other triangle is AC, so that would be X. So those two correspond with each other, so the ratio is 4 over X. And that's going to be equal to, and since we started with the smaller triangle, triangle DBE, we had started with a 4, we have to come back to that. We're going to start with the other side that we have. That's going to be 6. And the corresponding side in the larger triangle, triangle ABC, is this here, 12. So your proportion is 4 over X is equal to 6 over 12. To solve this proportion, you're going to cross multiply. So we have 6 times X is 6X, and 4 times 12 is 48. And then we're just solving this equation. So 6X is equal to 48, divide by 6. Those cancel each other out, and X is equal to 8. Therefore, we can say AC is equal to 8. Okay, so that's one example. Number 2, in the triangle below, AB is equal to 12. Okay, so right away I'm going to start labeling. So we have AB is 12. AD is 16, so that's this larger side on over here. AC is equal to 9. What is the length of AE? So we don't know this side. So again, it's a confusing diagram when it's all overlapping and we have labeled overlapping, so we're going to redraw our triangles. So we have one triangle, that's triangle ABC, that's the little one. So we have A, B, C, and we know that AB is 12 and AC is 9. And then we have the larger triangle, ADE, and we know that AD is 16 and AE is X. So now we're going to set up our proportion. If we take a look, we could start, really start anywhere. I just typically read left to right, up to down, so I'm going to start with this side here, AB. That's going to be 12. That side corresponds with AD in the larger triangle, that's 16. And this is equal to, in the small triangle again, we come back, that's the one we started with. AC is 9. And in the larger triangle, AE is X. So that's our proportion. We have our corresponding sides. And now what we're going to do is cross multiply. So we have, I always like to start with my variable. I like my variable on the left-hand side. So we have 12x, 12 times x, is equal to, and 16 times 9 is 144. So then all we're going to do is divide by 12. This cancels out, and x is equal to 12. So therefore, AE is equal to 12. Sometimes you have to go back and find a missing piece of a side. You might be asked to find, for instance, the length of CE. If this is 12, then you would just say that CE, you would subtract 12 minus 9, and you would get 3. So you could find all of the missing pieces if needed, but in this case we were asked for AE, so AE is 12.